This is a bit of a tutorial video. Having introduced you to the idea of the tangent ratio. Tan x equals opposite over adjacent. That's the formula that we've just been learning about. Then what I'm going to ask you to do first of all is have a go at these questions, or at least the first one maybe. The answers are coming out. I'm going to work through them on the next couple of slides, so that'll give you an opportunity for you to try them first. You want to try a few of them and then check your work, great. If you want to try the first one, and then you can zoom on ahead and watch my explanation, and then maybe go back and try some of the other ones. Okay, so pause it just now, decide what you're going to do, and then I'll catch you in a moment. Okay, so let's have a look at the first three questions here. So we've got right angle triangles, and in each case we're trying to work out the letter that's marked on each one. So the first one in blue, let's have a look and see what we've got. We've got a right angle here, which means that this side is the hypotenuse. With 25 degrees is marked in there, so that's going to be the opposite. And the other side is going to be the adjacent side. So according to our rule, I'd like you to write down at first, we know that it's tan at the moment. It's not always going to be tan, but for the moment it is, and the formula is tan x equals opposite over adjacent. I'd like you to write that down every time, as you do with any formula. Now we want to substitute in the three things that are in here. So x is an angle, and opposite and adjacent are two lengths of the triangle. So x, the angle, not to be confused with the x on the side there. It's really important that x is just a general letter for the angle. So having just talked over it, what we need to do is to make sure that the angle tan 25, okay? So whatever the angle is goes in there, and opposite and adjacent come from the sides. So opposite, it says x here. So that's our x now, which is a different x than in the formula. And the adjacent is 8, so I've got 8 here. And in the examples I gave you in the last video, what I said was if we're dividing by a number on the bottom, then you have to multiply by the same number in order for them to cancel out. Divide by 8 and multiply by 8 are inverse operations. So we can multiply the right hand side by 8, but remember we have to then also multiply the left hand side by 8 as well. So what we've got on the left is 8 multiplied by tan 25 is equal to x, because the 8's cancel out on the right. So x, the number that we're trying to find, is calculated on your calculator. You just type in 8 multiplied by the tan button, and then the number 25, press equals, and you get 3.7304. Write it out as to a few decimal places, 3.7304. Now we're always going to have to round it, so at the moment I'm suggesting one decimal place is good. 3 significant figures is also another one, depending on the kind of size of the numbers. So if we round that to one decimal place, the next digit 3 says round down, so we're going to keep the 3.7 as 3.7. Have a look at the units of measure. These are meters, so the answer is x equals 3.7 meters to one decimal place. There we go. In the second one here, this red triangle, let's do this again. We've got a right angle, so there is the hypotenuse. 75 degrees is the marked angle, so across from that is the opposite, and the other one is the adjacent. I'm trying to find this height t, so what I want to do, I think I'll use red to make it different. The formula is tan x equals opposite over adjacent. So what do we put in our 3 places? Remember the x is to do with the angle, so tan 75 degrees is equal to the opposite side. If I'm looking around at my labels, the opposite side is the t, and the adjacent side is the 3. So this time I've got tan 75 degrees equals t divided by 3. There's that fraction again. Well, we're starting to get familiar. Multiply both sides by 3. Why? because then the divide by 3 cancels with the multiply by 3 there, and that leaves us with our letter T on its own. That's exactly what we want. So on the left hand side we've got 3 times tan 75 equals, on the right hand side we've just got the letter T. Perfect. So T is equal to, take your calculator, 3 multiplied by tan 75 equals 11.196 and so on, 11.196 da 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 da, and then we can round that. Let's do it to 1 decimal place still. Now watch, the 9 says round up, so we round up from 1 to 2, so it's going to be 11.2. Units are meters to 1 decimal place. There we go. T is 11.2 meters. And lastly, what we got? We have another right angle triangle. There's the right angle, so away from that is the hypotenuse. Hopefully you should get quite quick at doing that. There's the marked angle, so over here is the opposite, and then the other one's the adjacent. What's the formula? I'll use green here. The formula always is here, tan x equals opposite over adjacent. Substitute in for the 3 things. The angle, tan of what? Well, the marked angle is 57 degrees, is equal to, opposite is A, and the adjacent is 20. So this time we've got tan 57 equals A divided by 20. We can deal with that equation by getting rid of the divided by 20, and that's by multiplying by 20 on both sides. So that cancels out, and if we rewrite that, it becomes, to keep my green, it becomes 20 tan 57 equals A. If you want to keep writing the multiplication sign in there, that's absolutely fine. 20 times tan 57 equals A. Flip it around. A is equal to, take your calculator, 20 multiplied by the tan of 57 equals 30.797, 30.797, and so on, dot dot dot. Cut it after 1 decimal place. The 9 tells us to round up, so A is 30.8 centimeters to 1 decimal place. Okay, so that's the first 3 there. I'll kind of quickly go over the next 3. So if you haven't already done the next 3, go back and look at the first slide, have a go at them, and then flip on ahead here, and I'm just going to go over quickly the last 3. Okay. Okay, here we've got the last 3. Let's just quickly go through these. I think it sometimes helps just to see it if you've got a particular problem with one of them. So here we go. Let's take this one here. Right angle, opposite it is the hypotenuse. Marked angle, opposite is the opposite, and the other one is the adjacent. The formula says tan x equals opposite over adjacent, and substitute in tan 63 equals d over 2.5. Multiply both sides by 2.5 so that we can cancel out the fraction there, which leaves us with 2.5 times the tan of 63 is equal to d, and then we've got d is equal to 2.5 multiplied by the tan of 63 is 4.906, 4.906, and if I want to round that to 1 decimal place, that'll be 4.9 meters to 1 decimal place. There we go. Next one, we've got right angle here. Opposite that is the hypotenuse. Oops. Marked angle is 19 degrees, so that side's the opposite, and the other one is the adjacent. So, here's the formula. Tan x equals opposite over adjacent. Substitute in, the angle is 19 degrees. The opposite side is marked as, actually, wee mistake there. Sorry, the n, I've moved it. That's why if you didn't get it right, you can't do that bit yet. It should be n, that should be up there. So apologies if you're here because you're like, I don't know how to do that one. Because you'll be able to do it shortly, but not quite yet. So n should be up the top, and then adjacent is 9.6. So this time we have to multiply by 9.6. We've had a fraction that we multiplied it by. It doesn't matter if you're dividing by a decimal, you just have to multiply it by a decimal. So we've got 9.6 times the tan of 19 equals n, because they cancel out. So n is equal to 9.6 multiplied by the tan of 19 degrees, 3.3055, 3.3055, and so on. So if I round it to one decimal place, it's just 3.3. Check your units. Meters to one decimal place. Okay. And lastly, hopefully we're getting the hang of it. Let's label our sides. Let's write out the formula. Substitute in. Okay, and then multiply to cancel things out. And then refresh. Rearrange and calculate. Probably fed up hearing my voice just now. So tan 47 times 64, 68.631. Round that to one decimal place. 68.6 millimeters to one decimal place. Okay, so that's us worked out these different letters using the tangent ratio in trigonometry. We're going to go on to look at what happens when the letter is on the bottom of the fraction. You'll notice that basically we're using the same format here where we're multiplying through by a number because the denominator is always a number. What happens if it's the other way around? What happens if the number's on top of the fraction and the letter at the bottom? That's what the next lesson is going to be about. Okay, I hope that's been helpful.